We're exhausting our fossil fuels at an alarming rate. The costs of exploration and production are rising, which means that renewable alternatives are becoming more attractive. Climate change, CO2 emissions, and an increase in ecological awareness also result in a push towards sustainable solutions like sun, biomass, wind, water, and geothermal energy. All these sources are available for an unlimited period of time with no negative impact on the environment or our children's future. And they allow us to be independent of often volatile oil-producing countries. Regarding energy demand, an electrification of the use of energy is expected. Exciting new opportunities like fully electric cars will dramatically change the way we consume energy, while creating a positive impact on the environment. Many people are worried about the transition to this new energy era. They fear an economic shock and a disruption of their lives. That's why our researchers are hard at work to develop new and innovative ways of producing, storing, trading, and using energy.
The transition towards a new energy era with its accompanying challenges and opportunities will necessitate the development and integration of new technologies. At the same time, the energy markets will be in constant evolution and will not be the same as they are today. The production of electricity by renewable energy sources will be less predictable and will be more fluctuating. To make optimal use of these intermittent sources, the end user will be stimulated to match his energy demand to their production. This, of course, will lead to changing tariff structures and incentives, which in turn will lead to new roles and changing roles in the energy markets. For example, there will be a new role for the flexible consumer, and the role of the distributed producers could become of major importance.
VITO's research focuses on all topics related to the new networked energy system and the energy markets associated with it. Distributed energy sources will be installed locally, turning every building into a potential producer. This is a huge change compared to the current situation. The challenge in this networked system is to keep supply and demand in balance at all times. After all, many renewable energy sources like wind and solar power are variable, creating peaks at times and shortages at others. Demand can be flexible, but there are constraints like production processes that need to keep on running. A smart grid makes it possible to continuously maintain this balance between demand and supply and offer renewable energy at the lowest possible price, all without interrupting daily operations. The technology and the system architecture required for this are developed at VITO. The unique expertise at VITO and the state-of-the-art laboratories are available to our partners, both in business and in research. Our experts cover all aspects of energy technology and smart grids. The different test facilities and labs are integrated into a smart grids test infrastructure. The smart grid test infrastructure offers facilities to simulate a building, a neighborhood, and even a district, using a 150 kilovolt amp microgrid. The interconnected laboratories not only allow for simulation of the loads on the grid, both thermal and electrical, but also for their intelligent management and control. One of the labs is the Thermotechnical Lab.
The Thermotechnical Lab is specialized in stationary and dynamic energy measurements and tests. This can be done on all kinds of thermal energy systems such as boilers, heat pumps, combined heat and power, solar collectors and thermal energy storage, and especially the combinations of all those components. We can impose the same boundary conditions as the ones that happen in real life. Our unique control program can provide an endless number of heat demand scenarios to a set of heat-producing appliances such as micro-CHP and turbines.
Batteries are crucial for our energy future. to store energy, and for powering vehicles. The battery laboratory infrastructure is unique in Belgium, offering infrastructure to test batteries for their useful lifespan under varying conditions. The expertise in hardware and components is complemented by a knowledge of models and software for the integration of renewables in the grid. As the number of variable sources increases, the demands on the network grow exponentially, and balancing can become very complex. In our home lab, the developed control algorithms are tested on clusters of household devices. VITO developed Intelligator, a hard and software concept to optimally adjust demand based on supply at every single point in time, so-called demand-side integration. Combined with components like smart meters, these types of control system can provide balance during periods of high energy consumption.
Smart grids are complex systems. We need a lot of different fields of knowledge to come together to make them work. Just think of electrical engineering, information and communication technology, thermodynamics. Those are all fields that were completely separate in the past, and now they have to come together to make it all function as one smooth whole. And that is where VITO's real strength lies. Our laboratories are interconnected, our experts collaborate closely with each other, and that is where we want to make a difference to the future.
It's VITO's mission to make this new world of energy come true. We believe very strongly in smart grids and smart systems as crucial components of a more sustainable society. Help us make this vision of our future come true.